Hello everyone, welcome back to my channel. Today we'll be covering Unit 4 of Physics, which is energy transfers. Now the agenda for today is covering units, energy transfers, work and power, and lastly energy resources and electricity generation. Now first of all, for units you need to remember the unit for mass, which is kilogram, the unit for energy, which is joule, the unit for velocity, which is meter per second, acceleration, meter per second squared, force, which is Newton, time, which is second, and lastly power, which is watt. You need to remember the symbols too. Next up we have energy stores. Now there are a couple of energy stores. The first one is chemical, which is the food we eat. Then it's kinetic, which is the movement energy. Next is gravitational, which is the energy of the objects that are lifted up. Then elastic, which is from springs. Then thermal, which is from hot objects. Magnetic, which is from the object in magnetic field. Then electrostatic, which is by the charged objects. And lastly nuclear, which is stored within the nucleus. Objects which is stored in the nucleus. Next up we have a Sankey diagram. Now in any process, energy is not created or destroyed, it is just transferred from one store to another. Now this energy flow can be shown by arrows whose width is proportional to the amount of energy involved. The wasted and the useful energy outputs are shown by different arrows. So you need to be familiar with the formula for the efficiency, which is useful energy output is divided by total energy input into 100. And you need to be familiar how to draw a Sankey diagram. So for Sankey diagram, on the left hand side you need to mention the total energy, then and you'll point an arrow on the right hand side to show the useful energy, then another arrow on the right hand side towards the down side to show the wasted energy. And remember to choose the width of the arrows according to the amount of energy. Next up we have energy transfer methods. Now there are three energy transfer methods. The first one is conduction, which is the transfer of thermal energy through a substance by the vibration of atoms within the substance. Now what happens is that metals, as we know, are good conductors. Why? Because they have free electrons that can move easily through the metal, making the transfer of energy happen faster. So this is the conduction. Basically, where electrons are free to move, the conduction, it transfers thermal energy faster. Next up is convection. Convection, which occurs in a liquid or gas. Now these expand when they are heated because the particles, they move faster and they take up more volume. Although the particles, they remain the same size, but they become further apart, so they take up more volume. Now what happens is that hot liquid or gas that is less dense, so it rises into colder areas, whereas the denser, which the colder liquid or gas, that falls into the warm areas. And in this way convection currents, they are set up which transfer heat from place to place. Lastly we have thermal radiation, which transfers energy by infrared waves, and these travel very quickly in straight lines. Next up we have a little bit more explanation of radiation. Now radiation, we have light shiny surfaces or we have dark matte surfaces. So light shiny surfaces, they are good reflectors of infrared radiation, and they are good reflectors, but they are poor at absorbing it. Whereas dark matte surfaces, they are poor reflectors, but they are good absorbers of infrared radiation. Moreover, they are also best at emitting infrared radiation. They are also good emitters. So a dark object would heat up faster than a light one. And a good insulating material is a poor conductor that contains trapped air. So being a poor conductor, that prevents heat transfer. How it prevents heat transfer? By conduction, because the electrons are not free to move, firstly, and secondly there are trapped air, which also prevents convection currents. So it prevents energy transfer by conduction and convection both. Next up we have some formulas that you need to remember. The first one is for the work done, which is in joules is equal to force, which is in newtons, into distance moved, which is in meters. So work done is equal to force into distance moved, and work done is also equal to energy transferred. Next up we have gravitational potential energy, which is in joules. The formula for this is mass, which is in kilograms, into gravitational field strength, which is in newton per kilogram, and height, which is in meters. Next is kinetic energy, which is 0.5 or 1 by 2 into mass, which is in kilogram, into velocity, which is in meter per second square. Now which is in meter per second. You need to take velocity, the square of velocity. So the formula is 1 by 2 mass into velocity squared, and the simple equations will be Ke is equal to 1 by 2 mv square. Next up we have, now because energy is conserved, what happens is that the decrease in GPE or gravitational potential energy is equal to increase in Ke or kinetic energy for a falling object if no energy is lost to the surroundings. Next up we have power, which is the rate of energy transfer or the rate of work done. The power formula is energy transfer divided by time taken or work done divided by time taken. The formula for work done, we can mention work done or energy transfer both, because as we mentioned earlier that work done is equal to energy transfer. So we can mention both, we can mention any, it means the same thing. Next up we have energy transfers. Now the way that energy can be transferred, there are quite a lot of ways. The first is through wind. What happens is that kinetic energy from the wind that turns the blades, which are connected to a turbine. Then the turbine spins, which is connected to a generator, and finally generator takes the kinetic energy and transfers it into electrical energy, and this electrical energy is used forward. Next is by water. Now by water, the kinetic energy of the water that spins a turbine, which is connected to a generator, and this generator then again transfers the kinetic energy into electrical energy. Next up we have geothermal energy. Now what happens is that thermal energy from the ground that is used to heat water, which turns to steam, and this is passed through narrow pipes. The thermal energy has now been converted into kinetic energy, and this kinetic energy will be used to spin the turbine, and then turbine will spin a generator, which will again turn this kinetic energy into electrical energy. Next up we have solar heating system. Now in solar heating system, light energy from the sun is used to heat water, and so it is transferred to into thermal energy. Next up we have by solar cells. Now light energy from the sun, it is transferred by the solar cells into electrical energy. There is no use of generators here. Next up we have fossil fuels. Now the chemical energy in the fossil fuel, that is transferred into heat energy as it causes the water to evaporate as it is heated. Then the steam travels through narrow tubes. The heat energy has now been transferred to kinetic energy, and then the steam or the kinetic energy that makes the turbine spin, which is connected to a generator. Finally, generator converts this kinetic energy into electrical energy. And finally, the last one is nuclear energy. Nuclear energy is transferred to heat energy as it is used to heat up the water. Then this heat is transferred to kinetic energy, which spins a turbine, which is connected to generator. Then finally generator again transfers the kinetic energy from the turbine into electrical energy. With that, we are done with energy transfers. Next up we have the advantages and disadvantages of energy resources, and this is the last subtopic for this unit. So now you need to be familiar for these energy resources, which ones are renewable, which are non-renewable, their advantages and disadvantages. Remember that this content is required for paper 2, not for paper 1. So now fossil fuels, that is not a renewable energy resource. However, it is reliable and it can produce large amounts of energy at fairly short notice, but it also produces significant greenhouse gases and pollution. Next up is nuclear. It is again not a renewable resource, but it is reliable and it produces no greenhouse gases or pollution, and a large amount of energy is produced from a small amount of fuel, but it produces dangerous radioactive waste that can take thousands of years to decay. Next up we have biofuels. Now this is a renewable energy resource, and this carbon dioxide produced while burning the fuel that is balanced by the carbon dioxide absorbed whilst producing it. But the disadvantage is that it can take a lot of land and consume resources that are needed for food production. Next up we have wind. Wind energy is again renewable energy resource, and it produces no greenhouse gases or pollution. Land can still be used for farming, but it is not reliable, and turbines, they can be noisy, they can be ugly, and they are not suitable everywhere. They only work where wind speed is high. Next up we have hydroelectric. It is again renewable energy resource. It is reliable, it can produce large amounts of energy at short notice, and it produces no pollution of greenhouse gases. But it can involve flooding large area, and it can also destroy important wildlife habitats. Next up is tidal, which is again renewable energy resource. They are very predictable, and a large amount of energy can be produced at regular intervals to them. However, very few suitable locations are available for them, and they can cause environmental harm to and disrupt shipping. Next up is geothermal, which is again renewable. It is reliable, and geothermal stations are usually small. Moreover, it can result in the release of harmful gases from underground, and not many places are suitable for this too. Next up, and the last one, is solar energy, which is again renewable, and it produces no greenhouse gases or pollution, and it is good for producing energy in remote areas, but it is not reliable. It only works when sun is there, and solar farms, they use up lots of farmland. So these are all of the energy resources and their advantage, disadvantage. You need to be familiar with them, which are renewable, which are non-renewable, and their advantages and disadvantages. With that, we're done with unit 4, and this is